Hi there, we're going to co-code an FPGA solution. Remember that um, co-coding is not vibe coding. Vibe coding is that you are coding without the knowledge of what is going in the background. Co-coding, you are a professional that manages the tool. So I assume that you know how to program and design FPGA hardware. So as you are already an expert, let's see how we are doing co-coding with FPGA design.
So in my Quartus project, I will open an empty project and I will put it there. And as you can see, this is a single file project with all the interface defined, but actually no code. I will compile it, even though it's like an empty file, but it will compile nothing, but at least it will give us all the structure of the project. And I will burn it to the FPGA, even though it's an empty project, just to see that it is being burned. Okay, so we got all the flow, and now I'm going to develop our project, but not in the UI. We're going to open Visual Studio Code with GitHub Copilot. That will be our co-coding environment. So this is my Visual Studio. I have GitHub Copilot extension with a GitHub Copilot account. And what we see, these are the files of the project that we just created. We can see our top here, which we saw in the Quartus environment. We have our chat windows. We will work in an agent mode, and I will pick the strong model, which is Sonnet 4. If you won't work with the strongest model, you will get like an experience that is disappointing. But Sonnet 4 is a very, very strong and smart model. And I'm going to talk with him. I'm not going to write anything today, just talk with him. I can chat here, and I can also transcribe. So I have my transcribe tool, and I will talk to it and paste everything here. So let's do that. So good morning. We're going to build FPGA project. You can browse and see all the documents in the directory. And what we're going to do is we're going to use this platform, the DE10 Lite, in order to build a digital clock. So we're going to use the 7 segments that we have on the board, where the two most left ones will be the hours, the middle one will be the minutes, and the right one will be the seconds. And also we're going to use key 0 and key 1 to adjust and set up the time. So key 0 will be when we press on it, it will start blinking the hours. And then we can, with key 1, set by pressing it the value of the hours. And then pressing the key 0 again will move to the minutes. And we can set it with key 1 again. And pressing it again, we'll get out of the setup mode. You can use the 50 megahertz clock that you have on board. And I want you to do it with build a module that will count the clock and generate a signal for the hours, a signal for the minutes, and a signal for the seconds. And also build module to implement the 7 segments. So it will receive 4 bits and output 7 or 8 bits to the 7 segments. And also you can do, all the counters, and if needed, a state machine or something, either on the top level or in a special module as you choose to. And I want every module to be in a separate file. And now, after I explain the project, please don't implement the project. I just want you to write the spec of the project in a markdown file, MD file. So just write the MD file so we can review it, and then we can continue if we are satisfied with what you will write. So I will put this transcription here, and we will let him write the MD file. So we can see he wrote the MD file, and maybe we should read this MD file. So I have an extension that will help me read this MD file. Let me, and we have FPGA digital clock project specification. Now, as a professional, you should go and read it. And of course, change it or ask for improvements or clarification, etc. But for the sake of the demo, I will assume that it's a perfect spec, and we'll go on and tell him to go further. Okay, so let's close this one here, and I'll go back to my transcribe. Okay, so now we can implement the design based on your spec. Notice that you're going to use the top level, which is the DE10 Lite Golden Top file, as your top level. And you should build all the modules, of course, but they will be instantiated in the top level of the Golden model. And also you can see I've put a run example.bat that can help you see how I usually run this kind of projects. So make your own run.bat file, but you can get the inspiration and the know-how from the run.bat example file. So let's go. Let's build a project. Let's see what you can do. So I will paste it here. And let's see if he understood what I've asked him. Okay, try to compile the first time. He has some errors. He will go and fix them. He found the syntax error. He will fix that, run again. It seems that he started to compile successfully, probably. I don't know it will functionally work, but we'll see. Now I'll stop him here because I think that he's trying to test it. And if he's trying to simulate 50 million clocks, it's problematic. So let me tell him, are you trying to simulate millions of clocks? Maybe you should just adapt to simulation mode. I don't know, I'm guessing that that's where he's stuck, so yeah, I was right, maybe. By the way, he did a separate clock frequency for real FPGA design and a separate clock for the simulation, so it will run faster. Okay, he says it's complete. Let's just ask it, is it compiled? Can I try and burn it to the FPGA? What do you say, sir? Okay, compiled and verified. So let's go back to the Quartus, okay? And let's see, here's all the design. I'll compile it here. Let's compile it here. I'll be okay, compiled it successfully. Let's see. So here he made the clock divider. He made the button control, the time counters for hours, minutes, and seconds, and display control, which also have all the 7 segments. Looks like he did a very nice job here. I wonder if it really works. So let's try and burn it. You don't believe it works. So let me set the hours and minutes, and I will show you. And I think it's very nice. Here you can see it. Simple as that. I didn't write a line of code, but as you can see, I knew what I'm talking about. And also, it's a very simple design. But if it were more complicated, I would have need to really track what he's doing, really design it with him, and not just let him do whatever he likes. So the difference between vibe coding and co-coding is that vibe coding, you just ask for magic to happen. And co-coding, you actually follow the design, ask him correctly, plan with him the architecture, writing documentation together, and make it work. That's how easy it is.